Hello folks, today we are going to see instantaneous velocity and speed. The velocity at any instant is obtained from the average velocity by shrinking the time interval delta t closer and closer to O. Like we can see here, delta t is closer to O. It's called limit here. As delta t dwindles, the average velocity approaches a limiting value, which is velocity at that instant. So we have delta, we have here dx, and delta t is dt. It's this approaches that we do this kind of approach to limit, to use the limit, and the idea that we have here a teeny interval, a little interval closer and closer to O. This is the idea about instantaneous velocity. So speed is the magnitude of velocity. Because if we are speaking here about instantaneous velocity and speed, we need to understand that speed is just the magnitude of the velocity. We say here the speedometer in a car measures speed, not velocity, okay? It cannot determine the direction. When we have the velocity, the direction is included in the idea. The speed, no, is just the value, it is just the magnitude, okay? The instantaneous velocity at a particular time may be found as the slope at that particular time of the graph of x versus t. So we will use here the graphs to find the instantaneous velocity here. We are here in the sample problem D because we have here videos about instantaneous, about average velocity, average speed, and now about instantaneous velocity and speed. So because we are here in the letter D. A position time graph for a particular movement along the x-axis is shown in figure below. Letter A. Find the average velocity in the time interval t 1.50 seconds to t equal 4.00 seconds. So to find it, we need to see here in the graph that we have here in 4 seconds 2 meters, in 4 seconds 2 meters, and here to 1.5, that is here between 1 and 2, 1.5 we have 8 meters, okay? So we need just to find it in the graph. When we find here, we will put here the final position, initial position, final time, initial time, that is called here x2 minus x1, t2 minus t1. So we have 2 minus 8 minus 6 meters, 4 minus 1.5 2.5 seconds, and we have minus 2.4 meters per second, okay? We have here a negative velocity here, okay? So we have here the letter B. Determine the instantaneous velocity at t.0 seconds by measuring the slope of the tangent line shown in the graph. We have here this line and we need to calculate, estimate, interest what is this slope. To it we will do an approach here, approach. The values as is approach. I will show it. We have a dx and a dt here, okay? So we have to this time interval, we have here almost 2. So I use it here these 2 times. 2.5 and 1.5 is almost 2. It's more close possible to 2 here. Then I can find some values. I have in 1.5 almost in 1.5 we have almost 7.8, almost 8, 7.8. and in 2.5 we have almost 3.9, almost 4. Okay, and we put it here and we find minus 3.9 meters per second. Okay, let's go to C, letter C. At what value of t is the velocity O? Is when the slope is like this, like is my hand here, is O, when the slope is 0 in t 4 seconds here. Okay, we have the time interval O. Here we have the a kind of deceleration, the particular stop and continuing moving is what we can say about this graph here. So let's go to see an exercise. Stop it now and try to find the velocity, the instantaneous velocity here in the Q point. Okay, stop the video and do. Are you correct now? It's almost it. Okay, it's almost it. Just to do some more exercise, do it now to the P point. Stop now. I will do now. Okay, so we have here almost 2,900 and here almost 1,300. Okay, here 2 almost 32, almost 18. Okay, same thing to here. Okay,